My name is Chef Chris Galarza. I am the founder of Forward Dining Solutions, also co-founder of EcoChef, which we can talk about at a later time. And I'm also a best-selling author, which I'm happy to say. I never thought I'd be people to say that out loud. What we do is we focus on designing commercial kitchens, working with operators to create a kitchen that is going to last them in the future, while also reducing their uh, their operational waste, right? Because we always, as a chef, I was always told, you know, let's reduce your waste by looking at what's in the trash can. What are you throwing away? But we never actually look at how much water is going down the drain, how much heat is escaping out the hood system, what other waste is out there. We also design and implement incentive programs throughout the country with utilities and governments. And we educate and certify commercial kitchens and individuals as well. Is this going to advance? There we go. Cool. So we're going to start off by just really wide overview of what is induction cooking, because that's what we're primarily talking about when we talk about electrification, talking about eliminating gas ranges and going towards induction. And obviously, induction is not gas, but this is what people primarily think of. I hope everyone can see my cursor going over the coils here. This is what we all know and love, grandma's coils. And this is what a lot of people think is induction, which is a glass top with the coils underneath that glows red. The truth is, induction cooking is a safer way of cooking that uses electromagnetic currents to heat up the pan itself. Essentially, it makes the pan itself the heating element. And the way it does that is by using magnets, essentially, to... Is this going to advance? Sorry, technical difficulties here. There we go. It's really slow. So it uses magnets to create what's called an eddy current. That eddy current sits about an inch or two off the surface and creates an oscillating magnetic wave that excites the ferrous molecules in the pan, the same way your microwave would excite the water molecules in the food to heat the food up. So it's a way of using electromagnetic currents to heat the food. It's works really, really quickly, and there's almost, if not no, wasted heat. So we're talking about efficiency that is far beyond the capabilities of gas. There are some pros and cons, though. There is a very high efficiency, right, as a pro with induction cooking. We're talking 80 to 93% versus 35% with gas. And I will say that 35% is a deceptive number. Truth be told, that is under lab conditions, with everything is at its peak. And speaking with some friends in the industry, more importantly with a good friend of mine, his name is Richard Young, which a lot of you already know, and some of the slides here came from him, so thank you for that. That number plummets to around 10 or 20%. It heats up really, really quickly. There is precise temperature adjustments, so I can set whatever temperature I set it to, it will be within 1 degree of that. There's a reduction in idling equipment in your kitchen, which means a lot of wasted energy that is just eliminated from the kitchen. There's no combustion, which means no carbon monoxide or other, VOCs and PM that can be a danger for one's health. There's a dramatic improvement of thermal comfort, which we will talk about, and there's also the extension of the life of your pots and pans. A lot of us who have been in the kitchen know that our saute pans or any other pan, they will warp, they will turn black underneath, which will mean that they won't heat evenly. There'll be hot and cold spots. This eliminates that. But there are some cons that we have to be honest about. There is an initial cost, right? We're seeing a 20% increase between gas and electric, depending on the pieces of equipment. But on average, a commercial kitchen is going to cost about that much more. But the operation side is what saves all of that. Whoa, what's happening here? Sorry about that. It just advanced on its own. There's also the compatible cookware, right? The folks are concerned about changing their cookware. Essentially, if a magnet sticks onto the bottom of the pan, you're good to go. And we can go through all the different pots and pans that work with it, but truth be told, it's easier to just go with the ones that don't. So all copper and all aluminum. Other than that, you're pretty much good to go. And there's also the electrical capacity, which could be an issue depending on where you live. So moving forward. There we go. Uh, what sort of equipment exists? Truth be told, there's nothing in a gas kitchen that does not have an electric alternative, and that includes your ranges, your griddles, your fryers, your kettles, your tilt skillets, your ovens, all of it. More importantly, induction allows us to refine the traditions uh, with what is going on here. I apologize, everybody. I'm not sure why it worked during testing, but I keep losing control here. The induction allows us to refine tradition. So the example on the left is an electric tandoor oven. The example on the right is obviously an induction wok. That induction wok has a tremendous possibility of savings because a gas wok is about 100,000 BTU jet engine that is putting a lot of heat into the space. And because of that, we're running constantly water to cool down this piece of equipment because we know that heat will eventually warp metal. This wok in particular is I believe, a 12 kilowatt wok that has the potential of eliminating that constant flow of water. So I've seen estimates where woks are using around 250,000 gallons of water per year. So we could drastically reduce that because they'll only use the water to clean up the wok and not cool down everything else. There's also the big matchup for folks, right? They want to know, how is this going to compare gas cooking versus electric cooking, efficiencies, and all that fun stuff. So to make this the most, and this is a slide that came from Richard, but to make this something that isn't a total blowout, we're going to say that this gas range is about 50% efficient. I haven't seen it, but we're going to see that. We're going to say that that's what it is. You'll be able to cook 38.6 pounds of food per hour with that. It's going to need time and elbow grease to clean. And for those of you who've never cleaned a gas range properly, let me tell you, it is a time-consuming thing because what happens is you turn everything off at the end of the night. You turn off the pilot lights. You scrub all the food particles that were on that got caked on throughout the service. You take the grates off, put it into a sink with degreasers and hot water, and then you will pull the burners off, and then take a toothpick and go through every single little hole and make sure there's nothing obstructing the flow of gas, and you will soak that as well. While that's gone, you'll scrub everything out, the outsides, the tops, everything. Dry that off. Underneath these knobs here is a drip tray. You pull that up, you dump all the contents out, you pull all the foil off, you degrease that, you clean that, you reapply the foil, you put the drip tray back in, you didn't go back to the sink, try to scrub everything that was dislodged by the degreaser off, dry that off, and then reapply everything, turn on your pilot lights. If you do it right, 20, 30 minutes of your time will be on just this piece of equipment here. All the while, they can cause burns and fires. But on the flip side, with induction, we're talking 90% efficient. We're talking a true 90% efficient, right? So in other words, when you lift up the pan, there is nothing. The pan essentially acts as the catalyst that closes the circuit, which allows the energy to flow through. When you remove that, there's no energy flowing through. With gas, why the efficiency plummets is when you lift the pan up to serve or anything like that, when the fire is still going, that is energy that is coming in that is not reaching the food. And that's why the efficiency plummets so much. Which means that 90% is a true 90%. You'll be able to cook 70.9 pounds of food per hour. It's going to be easier to clean. It's going to be safer to use. And to clean it, simply hot soapy water, you wipe it down, that's it. 60 seconds. So you can imagine the savings in labor alone in cleaning these, induction pieces of equipment versus the traditional gas. So when we talk about efficiency, what we're saying is the energy coming in versus what is actually hitting the food. So for the 35% gas range, only 10,000 BTUs is reaching the food. Again, that plummets, but we're going to say that the lab conditions are correct. On the low end with induction, we're reaching 14,000 BTUs, which is why we're able to cook so much more. With a wok, we're talking on average 20,000 BTUs are actually reaching the food. And that example that I showed you earlier of the induction wok, we got 35,000 BTUs. We actually have these woks installed in Microsoft, the project that I worked on early on. and they don't even go past half power. It's just too much. And that whole kitchen is producing about 10,000 meals a day. So production, check. Demand control kitchen ventilation is a big one. This is actually one of my favorite pieces to install in a commercial kitchen because that is where it's the most savings are. We are able, so this example was in the kitchen at Chatham here in Pittsburgh at the Eden Hall campus. And it was a demand control kitchen ventilation system with remote monitoring, heat recovery, and it saved the campus a tremendous amount of money. And we'll see how. And the way it did that was it had these sensors that would be scanning the cooktops. So as things got hot on the cooks, whenever the cook started to cook, it would ramp up. And then as the internal ductwork reached a certain threshold that we would set, then it would continue to ramp up. So it allowed us to really fine tune how much air we were moving in the kitchen, how much heat we were moving. It also had the added benefit of working with our geothermal system. So as the propylene glycol came from the geothermals about 500 feet down, the hood system would capture the heat coming off of the cooking and use that to warm that propylene glycol up to around 70 degrees, and then they would pump it through the floor to radiate out. There was no air conditioner. As a matter of fact, we only heated the building. We never cooled that building down. Didn't matter if it was summer or winter. It was purely just to heat this building up. The ventilation hood system, you can see here, is at about 94% efficient, which means it's only using 6% of the energy it would normally be using. And that's again, the amount of savings you can have here is just astounding. It was able to track efficiency in real time. It was able to identify errors, each usage for each individual hood. We can see exactly what was going on at any given time and adjust it, remotely. So this graph is where the big savings comes, right? So we had, as we were building this kitchen, we had the decision to make: do we put a constant flow hood system, which essentially someone comes in the morning, turns it on, it's at 100% power all day until someone turns it off, or we can have the demand control, which cost, and this is where the true cost disparity comes in, 3 times what a normal induction system would cost. So the red bar would be a $100,000 system. This green bar would be about $300,000. The reason we went with this is because of the savings. So because it ramped up and down based on what we were doing throughout the day, we actually beat projections, which projected us to pay it off in 14 months. We actually paid it off in 9 months, meaning that the campus was saving around $100,000 a quarter just in energy consumption, right? And that was a tremendous savings, obviously. And once you pay that off, those savings are in perpetuity. Thermal comfort is also a big thing. As we all know, commercial kitchens get very hot. Thermal comfort, as it's studied, is broken up into three pillars. What Mother Nature, right? Things you can't control: the air velocity, the outside humidity. What you as an operative or the building owner can control: the air temperature or the piece of equipment that put out radiant heat, and you as the individual. What are you wearing? What are you doing? All that contributes to thermal comfort. ASHRAE did a study where they tested over 100 commercial kitchens between summer and winter conditions, and depending on the humidity level, they determined the optimal thermal comfort zone between 68 and 82 degrees Fahrenheit. And they found that unless you were prepping or cleaning, there was almost no comfort in the kitchen. Once you started cooking, the kitchen got very, very hot, very, very fast. In fact, there was an article that came out in the New York Times last year that was talking about kitchens regularly hitting 130 degrees Fahrenheit, which has been my experience. It is a really difficult environment to work in. And in the Chatham kitchen, where I was talking about the ventilation, we did a study where between September 9th, 2019 and September 16th, 2019, and you can look it up in Gibsonia, Pennsylvania, the outside temperature was anywhere between 85 and 90 degrees Fahrenheit. There wasn't a cloud in sight. It was a perfect summer week. And in my kitchen, during prepping, during cleaning, during cooking as well, we never hit 74 degrees Fahrenheit. That's this top line here. So that is between the traditional kitchen and now the kitchen of the future, that is a 60-degree drop. That is a massive drop. That's, again, further savings because, sure, people may say gas is cheaper pound for pound. It's all in how you use it. If you're only using 10% of it, 20% of it, and then the rest is heating up your kitchen, which is increasing the cost of your electricity because now you have to cool this kitchen down, and you're moving all this tempered air outside, and you're constantly trying to cool or, you know, find an equilibrium of temperature within the kitchen. That is an incredible amount of waste that we're trying to eliminate. So we couldn't go into everything, but just a kind of quick summary. The benefits to electrify is that there is near elimination of idling equipment. As you can see here, this is from Stanford. There was a walkthrough with an engineer friend of mine who sent me this video and asked, why is this on when when they're done serving? And the answer is because you never know when someone wants some, like a burger or anything like that. But the truth is that's probably been on since 6 a.m. that day, and this was being broken down around 1. It's just on. It's just the cost of doing business. Electrifying is going to reduce your building's emissions, which is going to reduce your environmental impact, is going to increase your operational efficiency, which is going to save you a ton on energy and utility costs. There's precision cooking controls. There's dramatic improvement of thermal comfort. It's going to extend the life of your pots and pans. It's going to be easier to clean, which is going to save you on chemical costs. There's also a faster throughput, which is going to increase your productivity, and your dollar per labor hour is going to be drastically improved. And there's also, of course, the improved indoor air quality aspect as well. Before we close out, I just want to say that we are conducting a first of its kind study with our partners at PSE, where we are going into commercial kitchens and studying the indoor air quality of these kitchens. And we are looking for kitchens from across the country. This is going to be, I would say, one of those studies that is going to make a lot of people angry in the best possible way. And I think it's going to direct a lot of attention to the built environment. The data that we're seeing initially is pretty alarming, and we are paying folks to allow us into the kitchens. The data that we collect will not have their information publicized, but they will get a copy of the data ahead of time. And yeah, it's going to be a pretty incredible thing. So thank you all for your time. If there's any questions, we'll handle that at the Q&A portion.